So here's an example of our constraint type optimization, right? So here we're going to optimize height given the constraint of, well, here I have something a bit funny, right? Because some jerk drew an anarchy symbol on here. So I've got a circle that's drawn on the rock, right? But of course my constraint should live in the, where should my constraint curve live?
We're looking down at it.
Yeah, I should really be looking down at it, right? So really, to see what that constraint curve looks like, we should come up here and look directly down at it, right? And so now I'm looking at kind of an off ellipse, right? We're looking at this anarchy circle here. But if I look down at it, right, it's an ellipse. And so I'm trying to maximize height over that ellipse. And what's the highest that thing gets? Yeah, the top, right? My level curve here just barely kisses the top of that graph, right?
And the gradient.
Yeah, that's where the gradients are going to be parallel, right? Because the highest uphill on the steepest uphill direction on my rock is going to point straight up towards the top. And the steepest uphill from my circle, right, is going to be perpendicular to the level curve, right? So it's going to point in that same direction. You guys see that? Yeah, and then down here at the bottom, right, the gradient on the level curve is going to point that way, maybe. And the gradient on the rock's pointing up, but they're parallel. You guys see that? And again, that's right. Here's a level curve that's a little bit too high. It hits a couple of times. Here's a level curve that's a little bit better. It still hits a couple of times. And here's a level curve that hits perfectly, right? Just once across the bottom. Does that help your visual a little bit? Questions, things?
I'm still kind of confused on how the two gradients are, at least at the bottom, different. So like the gradient of the constraint is pointing downwards.
Yeah, so this depends a little bit on what the function is that gives me that constraint. But in general, it's going to point, right, I'm looking down at this ellipse, and the gradients for that ellipse function are going to either point both out from the inside or both in from the outside. Yeah, they'll be perpendicular to the level curve, but on this one, like, you know, maybe this one on the bottom is pointed out, and the one on the top is also pointed out. So I'm kind of looking down at those, really. I keep saying things and pointing gradients this way, right? Those gradients are two-dimensional vectors. They point flat. Does that kind of make sense? Right? They tell you which direction is the steepest increase. They don't tell you which direction and how fast. The magnitude is the thing that tells you and how fast. Cool?